For almost 100 years, we have known that the universe is expanding. And we have traced its expansion back in time, through to the very beginning, when the universe occupied an infinitesimal point in space. This was the state of the universe at time t equals 0, over 13 billion years ago. It is from this starting point that everything we are familiar with came into existence. Protons, neutrons, stars, galaxies, even space and time itself are here. At time t equals 0, this point began an unprecedented inflation. In this instant, time and space were born. And this event has become known as the Big Bang.
The galaxy from above, so to speak. A tightly wound spiral of billions of stars, all of them orbiting the galactic center. The spin of objects in space produces colors. It's called the Doppler effect. Apply it to a galaxy, and the stars moving toward us appear bluish. Their light is compressed. The stars moving away look reddish. Their light is stretched. It was the Doppler effect that gave astronomers the clue that galaxies rotate. In our case, it takes the Sun 250 million years to orbit the galactic center. There are millions of spiral galaxies like our Milky Way. Along the arms, pinkish clouds of dust and hydrogen gas where stars are born. But not all spirals are so tightly wound. This is a barred spiral. The center is quite distinct. Evidence is mounting that our own galaxy is a barred spiral. Some galaxies have no particular shape. Irregulars, like this, show few signs of forming new stars, and they're usually small. Biggest of all are elliptical galaxies. Some are shaped like a softball, others like a football. They grow larger by devouring smaller galaxies that drift too close. In this scene, a spiral galaxy is being cannibalized by an elliptical one. At least that's one theory.
But this, it's not a star, not a planet, not like anything we've seen. A ghostly specter more than 1,300 light years from Earth, Orion's dark cloud. Dust and gas shrouding us. There, deep inside, a light, pulling the dust and gas towards it, heating up, merging into a ball of burning hot gas. Like a star, like our sun, in miniature. Inside, it's millions of degrees. So hot it's beginning to trigger nuclear reactions. the kind that keep our sun shining, making energy, radiation, light. A star is being born. Orion's dark cloud is a vast star factory.
A searing burst of energy that cools and becomes matter. Is this how things began? Subatomic particles drawn into clumps by gravity. The formation of simple atoms like helium and hydrogen. Balls of hydrogen, bigger and hotter as their gravity grows. The birth of stars. Millions of stars in clusters. Billions of stars in galaxies. Our own galaxy, the Milky Way, contains 200 billion stars. One of them, our sun. A star is born from a ball of gas, squeezing denser and denser as gravity increases. Temperatures soar, nuclear fusion sparks, and the star begins to shine. In a continuous nuclear reaction, the star converts hydrogen into helium. All that prevents the star from exploding into space is the opposing pull of its gravity. But when the hydrogen runs out, the star begins to grow. It changes color. It's a red giant. With hydrogen gone, the star converts helium into carbon and then into heavier elements. In the biggest stars, when iron is formed, gravity prevails and the core collapses. The giant explodes as a supernova. Rich in the heavier elements, the debris blasts across the galaxy, material that, one day, will help form new stars. Such a blast may have kick-started our own star, the Sun, triggering the collapse of a cloud of dust and gas. More than 5 billion years ago, the condensing nebula contains everything that will make the Sun, the planets, and us. As the cloud collapses under gravity, pressure builds. The center gets hotter and hotter. At a critical temperature, nuclear reactions fire up, and the Sun is a star. Our Sun is too small to make the heaviest elements, so the iron that flows in our blood must be imported from the debris of a supernova. Today, the Sun is middle-aged, but in more than 5 billion years from now, with its hydrogen gone, our star will wane. But first it'll expand, getting redder and redder and fatter. The planets Mercury and Venus will be consumed. Earth's oceans will boil. Now a red giant, the Sun will melt the ice on distant Titan. Life could well take hold on this moon of Saturn. But its moment in the Sun will be brief. Its fuel spent, the Sun will dim and slowly shrink. our star will be a corpse, a white dwarf no bigger than the Earth.
This comet strayed too close. The sun's heat is boiling it away, creating a tail that stretches for millions of miles. It's freezing in here. There's no doubt where this comet's from, the icy wastes of deep space. But all this steam, and geysers and dust, it's the sun again, melting the comet's frozen heart. Strange, a kind of vast, dirty snowball, covered in grimy tar. Tiny grains of what looks like organic material preserved on ice since who knows when. Maybe even the beginning of the solar system. Say a comet like this crashed into the young Earth billions of years ago. Maybe it delivered organic material and water, the raw ingredients of life. It may even have sown the seeds of life on Earth that evolved into you and me. It must be Mercury. Get too close to the sun, this is what happens. Temperatures swing wildly here. At night, it's minus 275 degrees. Come midday, it's 800 plus. Burnt, then frozen. The Messenger space probe is telling us something strange. For its size, Mercury has a powerful gravitational pull. It's a huge ball of iron, covered with a thin veneer of rock, the core of what was once a much larger planet. So where's the rest of it? Maybe a stray planet slammed into Mercury, blasting away its outer layers in a deadly game of cosmic pinball. The goddess of love, Venus. The morning star, the evening star. She can welcome the new day in the east, say goodnight in the west. A sister to our planet, she's about the same size and gravity as Earth. We should be safe here. But the Venus Express space probe is setting off alarms. It's telling us these dazzling clouds, they're made of deadly sulfuric acid. The atmosphere is choking with carbon dioxide. Never expected this. Venus is one angry goddess. The air is noxious, the pressure unbearable. And it's hot, approaching 900 degrees. Stick around and we'd be corroded, suffocated, crushed, and baked. Nothing can survive here. Not even this Soviet robotic probe. Its heavy armor's been trashed by the extreme atmosphere. on to the moon. Dozens of astronauts have come this way before us. 12 walked on the moon itself. Just 250,000 miles from home. 3 days by spacecraft. Barren. Desolate. It's like a deserted battlefield, but oddly familiar. So close, we've barely left home. Neil Armstrong's first footprints. Looks like they were made yesterday. There's no air to change them. They could survive for millions of years. Maybe longer than us. The red planet. Unmistakably, Mars. For centuries, we've looked to Mars for company, for signs of life. Could there be extraterrestrial life here? Are we ready to rewrite the history books, to tear up the science books, to turn our world upside down? What happens next could change everything. Mars is the planet that most captures our imagination. Think of B-movies, sci-fi comics. What follows? Martians. It's all just fiction, right? But what if there really is something here? Hard to imagine, though. Up close, this is a dead planet. The activity that makes the Earth livable shut down millions of years ago here. Red and dead. Mars is a giant fossil. Wait, something is alive. A dust devil, a big one, bigger than the biggest twisters back home. There's wind here, and where there's wind, there's air. Could that air sustain extraterrestrial life? It's too thin for us to breathe. And there's no ozone layer. Nothing to protect us against the sun's ultraviolet rays. There is water, but frigid temperatures keep it in a constant deep freeze. It's hard to believe anything could live here. Back on Earth, there are creatures that survive in extreme cold, heat, even in the deepest ocean trenches. It's as though life is a virus. It adapts, spreads. Maybe that's what we're doing right now, carrying the virus of life across the universe. Even in the most extreme conditions, life usually finds a way. But on a dead planet, with no way to replenish its soil, no heat to melt its frozen water, all this dust, it's hard to see where we're going. Olympus Mons, named after the home of the Greek gods, a vast ancient volcano, 3 times higher than Everest. There's no sign of activity. Since its discovery in the 1970s, it's been declared extinct. Hang on. These look like lava flows, but any sign of lava should be long gone, obliterated by meteorite craters. Unless this monster isn't dead, just sleeping. There could be magma flowing beneath the crust right now, building up, waiting to be unleashed. Volcanic activity could be melting frozen water in the soil, pumping gases into the atmosphere, recycling minerals and nutrients, creating all the conditions needed for life. This makes the Grand Canyon look like a crack in the sidewalk. Endless desolation, so vast it would stretch all the way across North America. But here, signs of activity, erosion, and what looks like dried up riverbeds. Maybe volcanic activity melted ice in the soil, sending water gushing through this canyon. Underground volcanoes could still be melting ice, creating water. And where there's water, there could be life. The hunt for life is spearheaded by this humble fellow, the NASA rover Opportunity. It's finding evidence that these barren plains were once ancient lakes or oceans that could have harbored life. Look at those gullies. Probes orbiting Mars keep spotting new ones. More proof that Mars is alive and kicking. That water is flowing beneath its surface right now. Water that could be sustaining Martian life. Now all we have to do is find it. Maybe we've already found what we're looking for on Earth. Some think that life started here and then migrated to Earth. An asteroid impact could have blasted fragments of Mars, complete with tiny microbes, out into space and on to the young Earth, where they sowed the seeds of life. No wonder we find Mars fascinating. This could be our ancestral home. It could be we are all Martians. Jupiter. What a monster. At least 1,000 times bigger than Earth, so vast you could fit all the other planets inside it. Something this massive dominates its neighbors. Its gravity is pulling the asteroids apart. And it's breathtaking. But this beauty is a beast. It's almost all gas. Land here and we'd sink straight through its layers into oblivion. And Jupiter's good looks, the product of ferocious violence. It's spinning at an incredible rate, whipping up winds to hundreds of miles an hour, contorting the clouds into stripes, eddies, whirlpools. And this, the legendary Great Red Spot. The biggest, most violent storm in the solar system. At least 3 times the size of Earth, it's been raging for over 300 years. All these churning clouds must have sparked an electrical storm. Just one bolt is 10,000 times more intense than any at home. It's captivated our imaginations, haunted our dreams. And here it is, spinning before our eyes. Saturn, named for the Roman god who reigned over a golden age of peace and harmony. This planet's a giant ball of gas, so light it would float on water. Its spectacular rings would stretch almost from Earth to the Moon. There's the Cassini orbiter. It's picking up ghostly radio emissions, probably generated by auroras around Saturn's poles. This is the real music of the spheres. Cassini's telling us where these rings came from. They're the remnants of a moon shattered by Saturn's gravitational pull. Incomparable beauty from total destruction. Billions of shards of ice, some as small as ice cubes, others the size of houses. The god of the sea, Neptune. This world is covered in methane gas, and a storm as big as Earth, whipped up by savage 1,000-mile-an-hour winds. Back home, it's the sun that drives the wind, but Neptune's far away. Something else must be creating these ferocious winds